Good morning, good afternoon, good evening, class. This is Mr. Erosena, and today we're going to talk about structural isomers of organic compounds. Although, I guess mostly hydrocarbon compounds. We'll talk about structural isomers of hydrocarbon compounds. Now, what is a structural isomer? Okay, a structural isomer is, I should start off with saying what's an isomer. An isomer is they are compounds with the same chemical formula. So if we just write a chemical formula, these compounds have the same chemical formula, but their structures are different. Okay. Some of you might be wondering, like, well, how's that possible? Well, we'll go through a few examples of it, and there's actually several different types of isomers. The structural isomers is one type, and then we'll talk about geometric isomers and optical isomers as well. Okay. What the idea is that these compounds have the exact same chemical formula, so they're made of the exact same number of elements and exact same types of elements. But the elements are arranged in a slightly different manner so that the structures are entirely different. Okay, so let's start by going through an example of one. So let's write out, here's a compound, C, and I'll put the H's in explicitly. So this particular compound is a hydrocarbon. It's 4 hydrocarbons in length, so this is a butane. That's a butane. Okay, and butane has the formula as follows: C4, because there's 4 carbons, and H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. Okay. Now this next compound has the exact same formula as butane, C4H10, but it's not going to be butane. It's going to be something entirely different. Okay, so let's draw it out. So it goes C, and we'll do a branching C here. So there's my 4 carbons. And then let's put in my hydrogens. Hydrogens go in like that. Hydrogen, more hydrogens, and we'll finish it up. We have 4 carbons, and then we've added in, just one there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So notice, same chemical formula, but the structure is different. And actually the purple compound is actually an entirely different compound. This is only a 3 carbon chain. 1, 2, 3. This is a propane, and it has a methyl branch at the 2 carbons, so this is actually 2-methyl propane. Okay, so 2-methyl propane has the formula C4H10, and butane also has the formula C4H10, but they're entirely different compounds. The isomers have different properties, both in their reactivities and some of their physical properties as well. As an example, 2-methyl propane has a lower boiling point than butane does. Okay? And that has something to do with the way that the molecules are arranged. The 2-methyl propane molecules are slightly less attracted to each other than the butane molecules are attracted to other butane molecules. Okay. Right, let's go through another example of drawing isomers and naming isomers of the same compound. So let's start off with, let's say I draw a 5 carbon chain. And just for completion's sake, I will draw this as a full structure, complete with hydrogens. At some point, you don't have to do this. You'll just get used to knowing that there are hydrogens attached to the carbon. But for now, I will draw them in. So this 5 carbon chain is a pentane. But there are other ways I can draw this. So let's say I do the following. C, I could put a carbon there. And I'll put H's around it. And I still have, I should write out the formula for pentane. Pentane is C5H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12. This particular compound here is also a C5 compound, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. C5H12. But this compound is not pentane. This compound is something entirely different. Let's figure it out. Its longest chain is 4, so this is no longer a pentane. This is a butane. And it has a methyl group at the 2 carbon, so this is 2-methylbutane. Okay, same chemical formula as pentane, but structure is entirely different. And we could actually draw more structures of this. For example, you could draw the following. You could draw, let's see, C, 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 like that. And I believe this will still have 12 carbons. That's 3, 6, 9, 12. Well, this is no longer pentane. It's not 2-methylbutane. It still has the formula C5H12, but this time it's only a 3-carbon chain. So this is a propane. And notice that it's got 2 methyl groups, and they're both branching off of the 2 carbon. So this is a 2,2-dimethyl propane. There we go. And notice again, same formula. Same formula as the previous ones, but structure is entirely different. So that's what a structural isomer is. And it actually does play an important role when making organic compounds, because again, the structural isomers, even though they have the same chemical formula, the shape makes them different in their physical and their chemical properties. Okay, let's move on. So, a stereoisomer, I mentioned this briefly earlier, a stereoisomer, this is only found whenever there's a double bond. Okay, only found when double bonds occur. Double bonds occur. Okay. So, in a hydrocarbon chain, a double bond between carbons will result in the following structure. So carbon, 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 like that. Okay, now because of the way that the electrons are arranged, there's 2 possibilities for things branching off of this carbon. They could, if they're attached to other carbon, branch off like this, or they could branch off. So in this one, in the first one, they're branching off in opposite directions. In the second one, they branch off kind of in the same direction, like this. Okay. So in double bonds, this has because of the way that the electrons are repelling each other, this is the way that the shape is actually bent. Okay. In the first one, so label that one. Label this one A and label this one B. In case A, we call this trans. This is a trans isomer. Trans isomer. Okay. And then in B case, we call this a cis isomer. Okay. So in the trans configuration, the carbon chain sort of goes into the double bond, and then it continues traversing that way. Okay. In the cis configuration, kind of makes a sort of a U shape like that. Okay, and this actually does change the name of the compound. So let's go to an example of that. Okay, so for example, if I draw a pentane, I'll draw pentane. If I draw a pentane like this, there we go. So this is carbon 1, 2, 3, 4, 5. So this particular pentane, because of the way that, let's highlight that in red again, because it's sort of following that sort of, it's switching sides, we call this a, normally in the previous lessons we just call this a 2-pentene, because we have a double bond at 2, but because it could possibly bend the other way, we have to sort of specify this. So this is, then we just add the following in front of the pentene. We just call it a trans 2-pentene. So trans 2 basically means that the double bond is going to exhibit this sort of trans isomer behavior. Okay. On the flip side, if it exhibits this behavior, so there's this, we'll draw the same pentene, but it's going to be slightly different, like that. Okay, 1, 2, 3, 4, 5. So this particular this particular pentene would still be a 2-pentene, because we have a double bond occurring at carbon 2, but then we would call this a cis 2-pentene, because it's exhibiting the cis behavior, where it goes into the double bond and comes out the same, pointing in the same direction. Okay, and they do have slightly different properties from each other. Okay, for example, yeah, so they will exhibit slightly different properties. Okay, not nearly as different as the structural isomers we saw previously, but they will be slightly different. Okay. Now, these stereoisomers are only found in double bonds, because an interesting property of triple bonds is that the way that the electrons sort of hold up and repel each other, triple bond actually makes things very, very linear. So as a quick example, if I have a triple bond like this, the only way that the rest of the electrons go out is straight across like that. So triple bonds won't exhibit that behavior. Okay. All right, now an optical isomer, it's the last type of isomer we'll talk about. Optical isomers. Okay, these isomers occur when a carbon is attached to 4 different objects. Attached to 4 different things. Okay. So this only occurs when the carbon is attached to 4 different things. Okay. If the carbon is attached to if 2 of the things are the same, then this won't occur. Everything has to be different. So the easiest example is the following. If I have a carbon attached to a, let's just use halogen gases and a hydrogen, like this. Okay. I should probably draw a slightly more 3-dimensional shape. Let's see if I can do it. Okay. It's going to be a little difficult. Anyways, let's see if we can express it this way. So in this way, this carbon, which is attached to 4 different things, it could possibly occur that those 4 different things might attach in a slightly different manner. Like, for example, like this. Oops. Not like that. Let's put the H here and the BR there. Something like that. Okay. So notice the I and the H are in different places, but it is still the exact same compound. Okay. Now, what's strange about this is that the 2 compounds will actually exhibit slightly different behaviors from each other. but there's really no way to tell them apart other than drawing the structure. Their formulas will be exactly the same, and they will actually have the exact same name as well. It's just a matter of just making sure that when you make the compound, you make it in the form that you want to make it. Okay. All right. That's kind of all I really have to say about optical isomers. Just that. Now, a reminder again that this can only occur if the carbon is attached to 4 different things. When this occurs, we call the carbon, 4 different things. We call this carbon asymmetric. So, referred to as an asymmetric carbon. So when a carbon is attached to 4 different things, we call it an asymmetric carbon. Okay. Right. And that should do it. That's for isomers. Your assignment for today will be the following. Okay. Complete the practice problems on page 706. Only 2 sets of them, 18 to 19. And then the 22.3 assessment on page 707, numbers 20 to 25. Alright, good luck, and if you have any questions, you know how to find me.